You may be wondering, now I've had my mill for about 6 months. What have... Okay, you may have been wondering, what are my thoughts on the mill setup that I have now for somebody wanting to get an entry-level mill for their shop? I got this because I'm a knife maker, and doing more and more detailed, intricate mechanisms for folding knives has become very important. So I wanted a mill to add to the shop. But the thoughts that I had before I had a mill, how do they stack up to the thoughts that I've had now that I've had this in my shop for about 6 months and have been using it regularly? So this video is aimed at people who are thinking of getting a small mill for their shop, and maybe hearing the perspective of somebody that made that leap, got a small mill, and the decision-making process that I went through, what worked, what didn't work, what things that I was thinking that ended up being wrong, and what things that I was thinking that ended up being right. So use this as a bit of a guide to help you get started, I suppose. So when I was shopping for this, I did a lot of research. I mean, literally months of every night doing research, looking at YouTube videos, tutorials on how to do basic machining tasks and things. And I've decided I'm never going to post milling or machining tutorials or instructionals on YouTube, simply because it would take me years of work to be able to get to a point where I would feel like I could actually teach people how to use one of these things, and feel confident in doing so. Um, Plus, YouTube is filled with armchair warriors that likes to pick holes in machining techniques. So this isn't anything to do with the actual process of machining. This is basically me talking about, you might be on the precipice yourself of getting a small milling machine for your workshop. And it may be an intimidating thing to approach because there's a lot of different models out there. They all have very different specs, and you might not exactly know what you're going to be using it for. And so it's a big financial investment, even for a little one like this, to actually get that going. Now, the little mills themselves aren't that big of a financial investment, to be honest. They're cheaper than a 2x72 grinder in most cases. However, the tooling that they require to operate can add up to be worth more than the mill itself very, very quickly. So, which mill, what specs, what tools, etc. This is going to be aimed specifically at knife makers. So, when you're a knife maker, you don't necessarily need a big mill. If you've got the space and the budget, sure, bigger mills are better. But I do folding knives, and frankly, I use about 10% of the capacity of this one to do folding knives. So this thing would quite happily handle a buoy that's over a foot long if I was working on it, and it would handle it just fine. So what I'm going to do is I'm going to talk about the mill itself first, and my previous to buying and after buying thoughts about this particular mill, and what I've done to it, modifications, etc. And then I'll talk about the tooling situation, because what I did with my tooling, it led to a lot of questions from the community, a lot of sometimes criticisms, but there was a method to my madness, and I want to go through it with you as well. So the specifics of this mill is it's a Sieg brand, S-I-E-G, you can see that here. Sieg brand mill, and it's the X2L, and the L in this one means that it's an extra long bed. The more common version of this that you'll see is the X2D, has a slightly shorter bed. I liked the X2L simply because it was available, and I thought I'd rather have a larger bed capacity than I need than to have one that's too small, especially when you're putting tooling and clamps on it. One thing that I was very concerned about when I was going into it was its capacity for torque. And the torque that these generate is going to be based on two things. One is the gearbox, and one is the power of the motor. And this one only has a 350 watt motor. And I thought that sounds really piddly, really small. Let me tell you, this thing has not skipped a beat. This will go through carbon steel like it's butter. It's amazing. I can't do super deep cuts, but I can do 0.2 of a millimeter, so what's that? 1/8 thou passes through carbon steel with a small bit. I mean, like a 1/8 inch bit, 3mm bit, and it doesn't even slow down, doesn't even cause problems. So for working on folding knives, this has been more than enough power, and it's a good thing because this mill, the 350 watt, the X2L, is about, oh, this thing would weigh 60 or 70 kilos. And you want that. It's got a big cast iron frame on it, and you need it to be heavy and rigid in order to perform its job. So the next model up is X3D, I think it's called, or something, X3 something, or X3 series of Sieg mills. And they're about 200 kilos. So it's a big jump in weight. And in a small shop like this, where I basically have to be able to carry all of my tools, this one here, this is still a 2-person lift. And so if I had got the next one up, I would start needing cranes and hoists to be able to move it. And I'm really glad I didn't go for that one, because the one I was looking at in lieu of this one was called the X2 High Torque, I think. Sieg has a high torque version, and the high torque version had something like a 750 watt motor and, or no, 550 watt motor and an extra torque gearbox, which I thought I would need that torque. Turns out I don't, because I use fly cutters on this, and I even use big surface planing bits like this across, that do a very wide cut, and it doesn't even bog down slightly. So it's something to consider. You can get the lower wattage motor mills and it will do a damn good job. Once again, we're talking about knife making here. So, and I'll tell you what, if you're milling wood or G10 or any soft metal like brass or copper or something like that, forget about it. This thing just blasts through it so fast and so powerfully. You'll notice I've got a Jacobs chuck mounted in here. I will get to that in the tooling section. Any machinists or people that are machinist trained seeing me have a Jacobs chuck in a milling machine are probably going to be screaming right now. Don't worry, there is a reason for that. So upgrades to this thing. I have got the parts for the upgrade, haven't needed it yet. One of the downsides of the cheaper mills like this Sieg is that the gearbox in here is made of nylon gears. And nylon gears have a tendency to snap and break if they put under too much strain. And obviously if a tooth or something snaps off in here, that's a big problem. But there's a company called Little Machine Shop, and they sell an upgrade kit for this mill. It doesn't have to be this brand. This body of mill comes in lots of different brands. There's like 6 different brands that sell this exact same mill, and you can tell from the layout of everything here. And Little Machine Shop actually have one of them themselves, although theirs is already upgraded, so it's better to buy. If you're in America or Canada, Little Machine Shop, I would get theirs. But you can buy their upgrade kit, which basically turns one of these into the Little Machine Shop one, and that is to take away the nylon gears and make this a belt-driven system. And because it's belt-driven, there's no risk of teeth snapping off and things like that. I've got the parts, haven't taken the time to do it yet. It's quite easy to do. You just pop the Allen bolts, take it off, take the gears out, put the new belt system in, put it all back together, and it works. It's quite simple to use. So operation of it's quite simple. It doesn't have any digital readout for the speed, any sort of tachometer, so you don't know exactly what RPM you are running. One of the next upgrades I've got is actually a little magnet-based tachometer, so I'll put a little magnet on here, and the tachometer sensor will recognize how many times per second that's spinning, and it will tell me the readout. Another upgrade that I just haven't had time to do, but it's something I recommend doing because knowing your spindle speed is very important. But operation is very simple. You've got a safety here that's just a slap safety, so you can turn it off again. And you click that to enable the mill, and then very simple. Over the back, can't really see it here, but over the back there is a lever to be able to switch between high and low gears. Most of what you're going to be doing is going to be in high gear just because of the maximum RPM that this thing has, which is about 2500 RPM. Although, I will say, if you upgrade to the belt drive system, your maximum RPM will change to about 3200 RPM. And so obviously you've just got your either a large feed on the side, or you can lock it in and you can have a precision feed, which is a little loose. It's not the tightest tolerance thing in the world, but in terms of precision of movement, it's all there, and you can get very good precision out of this thing depending on the tooling that you have. So if you're shopping around to buy one, do take into consideration the weight. When you're looking at a model and you're like, yeah, that model mill is the one that I want, try and find out how much it weighs, because you need to have a plan in place to be able to get it into your workshop and up onto a nice solid workbench, because you want to mount it to something very, very sturdy. The workbench alone that this is sitting on is all steel framed, and it weighs twice as much as the mill, so it does a good job. It's not ideal, but it does a good job. So keep that in mind. Look up the weight. But in terms of operation of them, I'll leave that to better minds than mine. The guy that I was referencing at the start of this video is this old Tony. I highly recommend subscribing to his channel. It's just because A, he's hilarious, and B, he's like one of the kings of YouTube machining, and I learned so much from watching his videos. Another person that I recommend studying closely is Blondie Hacks. Blondie Hacks does incredible videos. There are others, but and they all deserve mentions, but I'll be here for a long video otherwise. Blondie Hacks and this old Tony were my main go-tos. In fact, Blondie Hacks has a playlist where she has a mill skills video where she just steps you through milling procedures, and I highly recommend watching that. Okay, so when it comes to the tooling that you're going to get with your mill, what I did is I do a lot of different things, and even outside of my sort of day-to-day work, I like to fix stuff. I'm a guy that doesn't throw stuff away. If something breaks, I like to fix it as best as I can. So I got quite a range of tooling for my mill, because when it comes to fabrication of replacement parts of things, there are so many goodies you can get for a mill. And only a small fraction of them actually pertain to knife making, so you don't need to get all the tools that I got. I got them for that reason. But certain things are absolute necessities that if you're going to get a mill, you have to get these things. Otherwise, the mill is going to be kind of pointless to own. So I'm going to go through the ones that I consider absolute essentials first, and then I'll show you some of the other goodies you can get. First thing you're going to want to get yourself is a good milling vise. Now, a lot of these come with a vise. It's awful. It's so imprecise and sloppy that it actually defeats the purpose of having a mill. The purpose of being able to have a mill is to be able to do parallel and perpendicular faces on things. So if your vise can't hold things steady and accurately and repeatably, then your mill is not going to function. So your mill is kind of only as good as the vise that you have with it. One of the most famous mill vise brands out there is Kurt, K-U-R-T. This is not a Kurt vise, but it is a Kurt style vise. I got this fairly cheaply. It's a 3-inch vise, and for these little mills, 3-inch vise is plenty. It's absolutely plenty. Mill vices usually come in 3 and 6, but there's lots of other sizes as well. Don't look at the 6 and think, oh, maybe I need that. This is a 3 mil, and look at it sitting on here. It's huge. It's plenty of room. So get yourself the best you can afford. Even this one, I think, was about $250, but it's done a very good job so far. Next thing you want to get that's an absolute must is a mill clamp set. These universal clamp sets, I won't teach you how to use them, but they're about $100, and they do a damn good job. Don't do what I do and get the wrong size, because it means you'll have to make your own T-nuts and things, which is fine. You can do that, but it's a good first milling project. But if you're in a metric country, it's probably going to be 10 mil for a small, like a mini mill like this. Or if you're in an imperial country, it's probably going to be about 3/8. DROs, you hear a lot of people say you absolutely need a DRO if you're going to get a mill. I kind of agree with that, to be honest. That being said, you can absolutely operate a mill without a DRO, and there is a certain argument that can be made that that's something that you should learn to do before getting a DRO, because this will spoil you. This will This makes using a mill so easy and accessible. However, they're not hugely expensive. You don't just get the DRO, you also get the sensor bars that get mounted to the mill. So I've got my X-axis one installed here, my Z-axis installed here, and my Y is down into here. Now I will say, installing these on any mill is a tricky process. Installing them on a mini mill, they're very cramped. There's not much space. I had to make special mounting brackets to hold them in place and get everything aligned. If you're not already at least capable with a certain amount of fabrication, then you're gonna have to learn quick. In order to be able to, you've got to mount, drill and tap the holes into the mill body, which is scary for the expensive toy that you just bought, sorry. And it starts, it's a intimidating process to install a DRO, a triple axis DRO, or any sort of DRO on a mini mill. Worth it? Absolutely, but it's tricky. So that being said, if you're at the point where your work is needing a mill in order to be able to progress, then you're probably good enough to be able to install it. So, swings and roundabouts. Another underrated tool for the mill is a good adjustable light source. Is something that I didn't get until well after I got the mill. Should have got it first up. I'm just telling you now, the ability to actually reposition and have a good bright light source to illuminate your work is hugely necessary. I'm thinking of having a second one mounted on the other side so that I can have more thorough lighting. This is just huge. You need light to be able to see what you're doing. So your workshop lighting is not going to be enough. You need spot lighting. I've seen some people mount ring lights around here that shine down. That's pretty cool, but yeah, get yourself even just cheap desk lamps like this. They'll do a good job. Next bit of tooling that I would consider a must is a set of parallels. When you first start out, you don't need to splash out for a really expensive set. Like, the more you pay for these, the more precise they get. The sort of work you're going to be doing, you don't need super precise ones first up. See how you go later and move on. These are not expensive at all. One of the cheaper tools, actually, a starting set of parallels. And these are basically machined blocks of hardened steel that are very specific dimensions. Very specific. I got some 4mm ones. One thing I did not consider was that most of the steel that I work with is 3.5mm or 3mm, so I will be getting a different set that are thinner. But for holding wider things, like when I'm machining bolster material, these work perfectly. So an absolute must, I reckon. And after a while, you can see down the bottom, you can start making your own parallels. They will be dodgy at first, but they will do the job, because the sizes that they will come in, I mean, it starts out very narrow and it gets very big, but the jumps between sizes are sometimes inconvenient size jumps. So sometimes you'll need to make your own, and it also depends on the size vise that you get. So get yourself a set of parallels. Just a cheapie will do you at first. Move on from there. Don't bother splashing out huge amounts of money at first on these. So in my drawer of goodies here, you'll see I have these. These are called Collets. And there's different sizes of collets. I went for ER32. And I got a ER32 collet chuck. So the way this works is you unscrew that, put the collet in, and then put that back in place, and it clamps down on the thing that you're trying to hold in the chuck. So I got a very inexpensive set of these as part of my tooling up process. And in general, you don't want to do that, because this looks round, right? But it may be round, but it's not concentric, which means as it spins, it kind of will move the bit around like that ever so slightly instead of spinning perfectly in place. It's a thing called run out, and it's very bad when you're milling with precision. So cheap collet sets have quite a high run out. So if you're trying to do something very precise, that run out, that wobble in your cutting bit is going to cause problems. The reason I ended up getting a cheap set anyway is because I didn't know what size Endmills I was going to get. Here you can see my collection of Endmills. Endmills are the main type of cutter that you use in a milling machine. They can cut a bit like a drill cuts as it's moving down. These cut as they're moving down or sideways or diagonal. They cut in every direction. So until I knew what were the most common sizes of end mill I would use in the work that I was doing, I didn't want to invest in a full set of collets. So you can buy cheap carbide. They call it carbide. It's not. But you can buy cheap end mill sets that come with like 8 or 12 different size end mills in the set. And they're pretty cheap. They don't last for huge amounts of time, but they do a fine job for when you're first starting out. And they're really good to practice with, but mainly they're really good to work out which sizes you use the most. And for me, that's 10 mil, 6 mil, and 3 mil. They're the ones that I use the most. So now I know that, my plan is to actually buy specific collets for the machine that are much higher quality. And I'm talking like $60 or $70 per collet, whereas that whole set was like $80. But because they cost more, they will be made with better precision and they will hold my end mills very, very steadily. So the way this works is you undo it at the top and you can slide this whole assembly out, take this collet chuck, stick it up in there, and then you can change the collets. The ones that I want to get actually are a collet unto themselves that are a bit longer, and they have the threading in there, so I can actually slide the whole collet up inside here, which actually gives me more clearance vertically as well. Since I only really need those 3 sizes, I now know, after getting the cheap set of these and the cheap set of end mill bits, where I need to spend my money, because buying an entire set of those expensive collet chucks or collets is is prohibitively expensive. So this way I can only spend the money that I need to. Which brings me to the Jacobs chuck. Now, a Jacobs chuck is what you would call like a drill press chuck, something that you can just tighten down with a key and hold whatever you want, drill bits, end mills, and things. However, these have 3 jaws in them that grip like this. And anything that grips with 3 jaws is inherently imprecise. So putting an end mill in a Jacobs chuck, and most mini mills come with a Jacobs chuck, putting an end mill in a Jacobs chuck is going to mean it automatically has that run out that we were talking about. However, the precision elements of the milling that I do only account for maybe 10-15% of the actual milling. The rest of it is a process called roughing, or hogging away large amounts of material imprecisely and sort of like hogging away up to the line so that you can then come in with a precise pass afterwards to shave off the last little bit. And for that process, I need to use several different size end mills, and you don't really need to move with super precision with those. So this is much faster. And usually in those operations, I'm also doing some drilling operations as well and reaming operations. So when I don't need super precision, I just keep the Jacobs chuck in there and I can swap bits in and out really, really fast. The big downside of these is that they take up a lot of vertical clearance, and mini mills don't have much. As you can see, this mill is in the absolute maximum position, and I have about 4 inches of space here. So you then put an end mill or a drill bit, and you've really not got much room. So they're a big compromise to use one of these, but that's why I have this in here. Next thing I'd say is fairly essential is one of these. This is one of the most fun milling tools to use. This is called an edge finder. They're very inexpensive, and basically it's a weird looking shaft that's actually sort of broken in the middle, and it's got a spring holding it together so it can swizzle. And you use them to precisely find the edge of a piece of material so that you can, once you know where the edge is, you can come in a very specific amount. It's a really great way to get precision in the parts that you need. So These are literally about 20-25 bucks, and yeah, you get what you pay for, but even the cheap ones do a pretty passable job. So the only thing you need to make note of is what size diameter the business end is. This is a 4mm, and because I know that's a 4mm, I can do my math calculations accordingly. Some tools you're going to have to build. I made this. This is called a fixture plate. I use this probably more than almost any other tool on the mill. This is something that is a machined block of aluminium, so the sides are exactly perpendicular to the top and bottom, and it is covered in threaded holes that are very evenly spaced. The position of the holes, not as important as the squareness of the piece. It's made of aluminium, which means I can put it into my vise, and when I put it in there, I can make sure that it's perfectly square to the work. And these hold downs let me hold really odd shaped pieces and do milling operations on them. Particularly good for pocket knives. This one is sized to fit pocket knives. Usually they're a bit larger than this. Fixture plates can get expensive, but they're fairly easy to make yourself, to be honest, especially if you have a little bit of experience using a mill. So if you can make your own parallels, you can make a fixture plate. Highly recommend taking the time, because it is a bit of time to go and drill and tap all of those holes, because they are all threaded. So take the time, it's worth it. Mills are messy, so as you saw in the start of the video, have a source of compressed air. At the very least, have something like this to blow away debris, because they make a huge amount of mess. So I always keep a small air compressor handy, as well as a small shop vac, and that allows me to keep this clean, because if the area is clean, then your work will be clean. So what about tools that are less necessary but handy to have? But side note before we get to that, did you know that I have merch? I have all sorts of merch, stickers, badges, t-shirts, you name it, I've got it. And I also offer online courses that teach you how to make various cool things. So check out the links below, and yeah, let's get back to the video. Rotary tables. These are particularly good for making folding knives, because you can relieve the liners. They're a little pricey, and you do need to modify them to work with folding knives. Topic for a different video. But if you're doing relieved liners on pocket knives, these are a must. Indicators. So you can get two main types. These ones here, and it's got a little plunger that as you push that in, it measures. And this type here, which has a little lever on it, and as you press on the lever, it measures. These are to measure very, very precise dimensions. You've got to be fairly careful with them. Don't let them fall, don't bang them into things. They've got these little magnetic bases, which are a lot of fun to play with, but these are, if you want to start getting into precision work, even cheap, nasty ones of these are a must to start with. And then as you get better and better, you progressively get into more and more detailed ones. There is a strong argument that could absolutely be made that these are in the mandatory kit for tools and not in the optionals. However, as a knife maker, I find I don't need to use them that often. But when I do need them, they're an absolute must. Fly cutters. Now these are a very interesting tool and an interesting addition to a mini mill. I would not recommend using these on a mini mill that does not have a belt drive system, simply because they, rather than being constant force on the gearbox, they are a whack, 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 whack sort of force, and that can cause a lot of strain. So basically what these do is you put them like that, and they spin around like this, meaning that there is only a single cutting point ever in contact with the work. And because of that, the amount of load on the gearbox is much smaller than it would be if you had a normal end mill, which is doing a lot of surface contact of cutting. So you can actually run one of these, and you can see they've got quite a wide throw as they spin around. And so if you need to finish off the surface of something very cleanly, fly cutters will do the job for you. And they usually come in sets like this. And you do need to be able to grind your own high-speed steel tools, which there's a great video which I will link up in the corner there from this old Tony on how to do that. I highly recommend you watching it if you're going to get into making your own high-speed steel tooling. And my final recommendation is to have an old paintbrush handy. Really good for just cleaning off detritus and things on the milling machine, because it does build up in all of the little grooves and cavities and things, and a simple paintbrush is enough to get it cleaned out and sorted pretty quickly. So not necessary, but it helps a lot. So hopefully you found this video useful in treating any sort of anxiety you may have about upgrading to a small hobbyist milling setup in your workshop. Obviously there's going to be people that have different opinions on what gear to get when you first start out. This is just from my own personal experience using this to make knives. So it's the stuff that I've found, which was quite surprising to me. A lot of the things, my doubts about what this machine would be capable of, have been completely allayed, because it has handled everything I've thrown at it and more. It's got its idiosyncrasies. Yes, it is a cheaper, lower end milling machine, but for what I do, it's doing a really, really good job. It hasn't missed a beat in the entire time that I've owned it. The precision needs to be upgraded on, like, getting the new collets and things like that. But even with the cheaper stuff that I've got, what I'm able to do with this is pretty impressive, frankly, for what it was. So definitely consider it if you're thinking about it. It's a big investment up front, but if you put it to work straight away, you can make that money back pretty quickly with the level of precision you're able to achieve with one of these things. So hopefully you've found this video helpful if you're sitting on the fence about making the leap. And I guess I'll see you all in the next video. Big shout out to my awesome patrons who have really carried me through this month, because this is the lead up to the 48-hour dagger challenge, and yeah, it's been pretty hectic. So big thank you to you guys. You really make my job so much easier, and I'm able to bring you content like this. So I'll catch you all in the next video. Hope you're doing well. Bye.